Assalamualaikum and hi. My name is Ayub Fakhruddin Begamli. My metric number is DN160036. Today, I would like to present my research, which is design improvement of handheld vacuum cleaner using design for manufacture and assembly method. So, let me start with introduction. Design for manufacture and assembly DFMA had been developed by Boothroyd and Peter Dewhurst in 1981. Which was then founded the Boothroyd Dewhurst Inc. BDI in 1983. The basic concept of DFMA is by applying the DFMA paradigm or software to analyze the manufacturing and assembly problems at the early design stage. So, DFMA technique has been applied extensively in industry field these days. The technique has grown fondness rapidly as a benchmarking tool as it helps define design and manufacturing capabilities of challenges. According to history, design for manufacture DFM was used by Ford and Chrysler in their design and manufacturing process of the weapons, tanks, and other military products before the Second World War. The DFMA software has paramount to structure and flexible design approaches. The DFMA application is to focus facilitating of manufacturing, assembly, and efficiency of product making process. These software products are used to help design process in almost all industrial fields. This DFMA strategy comes with great benefit, which is quantitative method to assess design, communication tools, and linking with other engineering disciplines and other departments and modularized with step-by-step for developing products. Then the DFMA analysis is performed and compute all the essential requirements and the most optimal design can be achieved throughout the analysis. So next is literature review and methodology. DFA has been taken seriously in early 1960s. The development of this method is to work and overcome benefit to the company who is using this method. DFA method should be carefully considered in the early stage so that it can estimate the cost and time with properly manner. The main purpose of DFA is to ease the assembly of products and for the DFA tools to help ease the designers toward the assembly issues. The original and the redesigned products are compared to show that the new design will contain lesser parts, hence reducing cost, assembly time, and operation. Furthermore, a product that has fewer parts will have increased quality because mistakes can be avoided. In addition, DFA methods are essential tools in providing feedback to the designers about the design efficiency from assembly viewpoint. Furthermore, the goals of DFA may be stated as the design for minimum part, easy to handle, easy to inserting and fixing, reducing or minimizing operations that do not add value like adjustment or reorientation. To achieve the stated goals, the DFA guidelines should be followed, which is lessen part counts and types, modularize the design, eliminate adjustment, design parts for easy feeding or handling operations, produce parts that can be self-aligning, assure capable access, design parts that cannot be installed falsely, use competent fastening or fixing strategy, reduce of handling or reorientation, utilize gravity, maximize part symmetry, and assure detailed design that easier assembly process. Meanwhile, design for manufacture DFM is to ensure minimal cost for production. The selection of appropriate processes for the manufacture of a particular part is based upon the matching of the required attributes of the parts and the various process capabilities. The process factors which influence a designer's selection of a particular material is raw material selection, process selection, develop a modular design, use standard components, design parts to be multi-usable, avoid separate fasteners, minimizing assembly direction. So next is methodology. The figure shown is my methodology project flowchart. So first, identify product to improve, then disassemble product and study part details. After that, evaluate the design efficiency of original design using DFA table or DFA worksheet. Then, after the result has obtained, is the result verified? If no, then we go back to evaluate the design efficiency of the original design using the DFA table. If yes, then we interpret result from DFA table of original design. Then propose product design modification. Then evaluate the design efficiency of improved design using DFA table. Then compare result between original and improved design. If the design is not improved, then we go back to propose product design modification. If the design improve, construct visual representation of proposed modification. Then finally, documentation and reporting can be done. So next is DFA worksheet checklist. So as the figure shown, we have the part number, part name, part quantity, part function, the alpha, beta, and alpha plus beta. Then the table consists of 37 parts. So Mr. DIY handheld vacuum cleaner has 37 parts. Next is results and discussion. So the first table is from DFA worksheet of original product. The design efficiency is the matrix design that expressed as a cost function that will help to reduce the overall number of components by focusing on the need of each part, and it will define the design, handling, and assembly time that affect the cost of the product assembly as shown in the table. The table shows that design efficiency of the original product is 0.3170262. Then for the final modification, the design efficiency is achieved with value of 0.5016969. It is a huge comparison to the original product. This is due to the DFMA method applied to the modified product. So the final design efficiency value that has achieved as shown in the table shown is due to elimination of middle body screws, canister cover screw, floor brush screws, inlet screw, and inlet at the canister body. Subsequently, the middle body cover is proposed to be set as part that is secure immediately using snap fit function. Even though each insertion type has changed, the manual insertion code does not change. But as the screw were removed, it gave a great impact to the total operation time and cost. So next, the DFA worksheet comparison between the original product, first modification, and second modification. So the table shows the comparison of number of parts, operation time, operation cost, and design efficiency between the original product, first modification, and second modification. The original product comprises of 37 numbers of parts, and it is reduced to 34 in first modification and to 31 in second modification. This shows the total reduction of part is 6 parts. Thus, the reduction of part is equal to 60.21% from original product to the second modification. This is due to the elimination of some parts from the original design. This elimination also affected the operation cost, which is reduced from 147.624 cents to 81.324 cents. Finally, the design efficiency value that is achieved is increased from 0.3170262 in original product to 0.4361589 in first modification. And then final modification is achieved with design efficiency of 0.5016992 with increment of 0.18 for 6753 from the original product. As for conclusion, this research is principally about the evaluate and analysis on the existing product and enhance the design of handheld vacuum cleaner using DFMA method. Throughout the research, DFA worksheet is beneficial to improve a product design. The final result confirmed that DFMA able to reduce the product complexity in which lower the number of parts and subsequently provide better operation time, operation cost, and also design efficiency value. Nevertheless, by using DFMA method, the handheld vacuum cleaner is redesigned and get more efficiency design with less number of parts and complexity. So that's all from my presentation. Thank you.